Hello and welcome to another Yum FSCC quarterly development training presentation. Today we are going to look at a plumbing situation called backflow. Backflow prevention is a plumbing code in the United States, but I'm not sure how much the rest of the world is required to follow this or any similar code. I'm sure many of you are not familiar with how plumbing works, and even less familiar with backflow issues. Because backflow prevention is a part of the FSCC, I want to give you a basic understanding in this training. There is only one standard in the FSCC dealing with backflow, and that is 10.2. We will look a little closer at the requirements of this standard later, but for now, let's start with the basics. First, what is backflow? Simply put, it is a reverse flow of contaminated water or other liquid directly connected to the water supply line as a result of a sudden change in water pressure. Now we're going to explain this a little more clearly in the next few slides. Why is backflow important to understand in a restaurant, and why is it dangerous? First, all the water in a restaurant must be clean and safe to drink, as well as to use for food preparation and dishwashing. If the water supply is contaminated, this can cause a direct cross-contamination of the food and utensils used. Second, it is the responsibility of the manager and team members to protect the water supply from becoming contaminated. This is not only important within the actual restaurant building, but for the protection of the entire neighborhood around the restaurant. As the specialist visiting the restaurant, it is your job to be able to identify when a potential backflow situation exists and let the manager know how to correct it. You do not need to be a plumber to understand backflow and how to prevent it, but it does help to have a little understanding of how water is supplied to the restaurant. Water flows under pressure from a source. This can be a water treatment facility, a well, or even a storage tank. The pressure can be formed by a pump or simply by gravity. Either way, in a normal situation, water should flow from the source to the restaurant through a water main line, and then through a system of pipes within the restaurant to the sinks, dish machine, ice machine, beverage station, or other location where water is needed. The water should always flow out when it reaches the end of the line, such as a sink, as shown here by the arrow. On the rare occasion when a backflow event occurs, the water supply can reverse, causing water to flow from the sink or other endpoint back into the plumbing pipes and even into the water main on the street. This is what we are referring to when we talk about back siphonage, or as we will simply refer to it for the rest of this training, backflow. So what can cause the water to flow the wrong way? Well, because a water supply system is under pressure, any disruption of the system can change the pressure. When the pressure outside the restaurant is lowered below the pressure inside, the water can flow backwards. Two examples that should help you understand this are shown here. First, I want you to think about a large main water pipe running under the street outside the restaurant. If that pipe should break due to the age of the pipe, or even a construction crew digging in the area, a large volume of water will quickly flow out of that water main pipe. The volume of water escaping that water main is significantly more than the amount of water in the small pipes located inside the restaurant. All the water escaping the main pipe causes such a pressure change that it can actually pull water from all the surrounding pipes, such as those inside the restaurant. A similar situation can be caused by a fire hydrant being opened on the street. If a fire were to occur near the restaurant, when the firefighters' hoses are connected and the hydrant is opened, so much water is drawn to this hydrant that the pressure on any surrounding water pipes, such as those inside the restaurant, can be reduced, and the water can again flow backwards towards the hydrant. There are other situations that can cause a backflow event, but these are two that should be easy for you to understand and begin to see how water can flow backwards. Now that you understand how and why water can flow the wrong way, we need to look at how contamination can occur in this process. Using the example shown here, water should flow in the direction of the arrow, from left to right. When a disruption occurs to the main pipe, as we just discussed, the water now wants to flow backwards, or from right to left. Now I want you to think about what would happen if a hose is connected into a bucket or a container of chemical or some other contaminant. As that water flows backwards, it will pull the liquid from the container through the hose and into the water supply line. When the water supply is fixed and begins to flow normally, this chemical contaminated water in the pipe will now flow out of the supply line and into the plumbing in the restaurant or the neighborhood, affecting showers, drinking water, and even manufacturing facilities, as you see here. This hose connection is known as a cross connection. A cross-connection is a direct connection between the water supply and a drain, sewer, or hose connection. Within a restaurant, there are several places where this can occur. A hose connected to a sink is a common place to observe this in a restaurant. Other sources of cross-connection can be found in the sink drain, ice machine drain line, and the carbonator at the beverage dispenser. Your job is to be able to identify these risks, alert the manager to the risk, and deviate for it on the FSCC report. The next process you need to understand is how to prevent backflow from occurring. There are two main prevention methods that you will need to understand. The first is an air gap. An air gap is simply a space provided between the water supply and any source of contamination. In the picture on the left, you can see some common air gaps on a sink. The first is the space created between the flood rim of the sink and the end of the faucet. The flood rim is the highest point water can reach on the sink before it floods. Typically, this is the top of the sink, as shown here. The distance between the water supply, or faucet in this example, and the flood rim should typically be 2 times the diameter of the inlet, or a minimum of 2.5 centimeters. Therefore, a 2.5 centimeter inlet should have a minimum 5 centimeter air gap. A second possible source of contaminated water is found at the drain. A direct connection between the sink drain and the floor or wall drain could allow raw sewage to back up into the sink. In a situation of extreme plumbing problems, if sewage would back up into the sink, and there is a cross-connection between the faucet and the sink basin, the raw sewage now could become the source of contamination of the water supply. Therefore, it is required that there is an air gap between the drain of the sink and the floor or wall drain, as shown here. If sewage should back up, it will now run onto the floor and not into the sink basin. Finally, another common cross-connection in a restaurant is at the spray sink hose. This hose should always hang with a nozzle or spray end above the flood rim of the sink. Sometimes the spring that holds it up will wear or be bent, allowing the hose to hang into the sink. This cross-connection can be corrected by adjusting the retaining spring or using a hook to secure the sprayer head, as shown here. The second way to prevent backflow is through the use of a check valve. A check valve is basically a device that allows water to flow in only one direction. If a backflow situation is created, the check valve functions to block the backwards flow of water. The device shown here is a large check valve used on larger water lines, but it is useful for showing how one works. As water normally flows in this direction, the pressure of the water keeps open 2 spring-loaded valves, allowing the water to flow in the correct direction. Should water begin to flow backwards, the normal pressure on the valve is released and it closes, creating a stop within the valve, and now water cannot flow in the wrong direction. The more common check valve you will see in a restaurant is shown here. This bell-shaped cover on the faucet indicates that it contains an atmospheric vacuum breaker. This vacuum breaker is shown in detail in the picture on the right. As water flows normally through the faucet, the water pressure holds the check valve up and in the open position. As soon as the faucet is turned off, gravity causes the check valve to fall down and close off the water supply from any backflow situation. This is called an atmospheric vacuum breaker because it uses normal air pressure and gravity instead of a spring, as we saw in the larger previous valve. When an atmospheric vacuum breaker is not installed on a faucet, a small threaded vacuum breaker can be installed on any threaded connection where a hose can be installed. Some sink faucets, such as a mop sink, will have a threaded end allowing a hose to be installed. If this faucet does not have an atmospheric vacuum breaker, as we just saw, a hose bib vacuum breaker should be installed. This functions like the atmospheric vacuum breaker on the previous slide, but it has a spring-operated check valve. As water flows through it, the valve is pushed open. As soon as the water is turned off, the spring closes off the water supply. Should a backflow situation occur, any contaminated water will hit this closed check valve and exit through the holes shown in the top picture. This hose bib vacuum breaker allows any hose connection to be protected from backflow. These are inexpensive and should be recommended anywhere you see a threaded hose connection without a built-in vacuum breaker. There are many other situations where backflow can occur. There are entire courses dedicated to backflow should you desire to learn more. This short session was designed to give you the basics to understand how interruptions in a water supply can cause a backflow situation. Whenever water reverses direction, any cross connection creates a path of contamination of the water supply. Cross connections can easily be avoided by the use of air gaps or check valves, such as vacuum breakers on sink connections. We mainly focus on sinks in this training because they are easier to understand, but backflow protection should be used anywhere contamination source is present. As the FSCC specialist, you should make sure to look for air gaps on sink faucets and drains, as well as on the drain line of an ice machine. In the picture on the left, you should check to make sure an air gap exists between the faucet and flood rim, the spray hose and the flood rim, and the drain lines in the floor. As you can see here, the spray hose is too low and hangs below the flood rim, and one of the drain lines is directly plumbed into the floor. These are both backflow deviations. Also, do not forget that the ice machine has plumbing. There should be an air gap on the drain line exiting the machine. This can usually be found around a floor drain under or near the machine. The bottom right picture shows what you will typically see, although any configuration that maintains an airspace should be acceptable. You should also be able to identify that a check valve of some type is present on a sink with a hose connection, such as a garden hose or even a chemical dispenser. In this picture, you can see the bell-shaped atmospheric vacuum breaker on the mop sink faucet. Most commercial chemical dispensers, like the one shown here, should have a built-in backflow prevention device, but it never hurts to ask the manager if they know for sure. Be sure to never open a chemical dispenser to check. If the manager is not sure, assume one is present and have the manager ask the technician the next time they are in to service the dispenser. One last area to check is the carbonator, or the machine that makes carbonated water for the soda machine. This device must have a check valve installed, as carbonated water is very corrosive and will dissolve copper pipe should it be allowed to back up into the water supply lines. In the bottom right picture, you can see the check valve here. This valve operates as we've discussed earlier by creating a one-way flow of water. If you're not sure or you cannot identify the check valve, make sure to ask. As you have seen, backflow can present a big risk to the water supply and the safety of those who use it. While there is only one FSCC standard dedicated to this, there is a lot that you should look for related to backflow during your restaurant visit. Backflow may not be something you have had any previous experience with, but I hope you now have a little better understanding of what it is and how it can occur. You should also now understand some simple ways to prevent it from happening, both within the restaurant and within the entire neighborhood. As you continue to visit restaurants, make it a point to look for backflow prevention devices and ask questions if you do not see any. This concludes the training presentation. Please log on to the test generator site on the screen using your login and password as you have before and take a short exam on backflow. You have also been emailed the exam website in case you did not have time to write it down. Good luck!